What kind of equipment are physicists using to
Mm,
look at these subatomic particles, to understand them, to study them?
Great question. Um, you can use as simple a thing as a prism of glass. You just have sunlight shining through and it breaks up the sunlight into its component colors. But what happens is if you break it up just right, then you can actually see streaks, not just of color, but of bright and dark lines in the color. And so the spectrum of the rainbow reveals the quantum structure of the atoms and molecules in the solar atmosphere. That's just one example. Now, if you take that, which was done basically a couple hundred years ago by astronomers and physicists, and put it into modern times, what we're doing is we're sending beams of subatomic particles, things that we know that we can control, but they are so small and they're so fast that we have to detect them through not just typical glass filters, but special kinds of structures that allow us to receive that information, decode it, and then come out the other side. We use electronic cameras that literally count photons as little pieces of light come in, say through a telescope or through our detectors or and big accelerators and so forth. Each piece of light has to be detected. And those electronic components are designed specifically to be able to convert whatever they detect into electrical signals, which can then be sent through our computers and our electronic cameras and so forth to make pictures or to make other kinds of measurements. So, really, a little bit of everything, but they come basically down to some of the real fundamental things that we do all the time. Every time you use a magnifying glass, or every time you see a color of the rainbow off a reflector on a bicycle wheel or something, there's quantum at work.
Wow.